Welcome to my channel. Your tutor Mariam is here. It's a 23rd video of Introductory Physics 1 and the 4th video I'm going to talk about the motion in 2 and 3 dimensions. That is the 4th subject of Introductory Physics 1. In this video I'm going to solve one example that I found it interesting. This example is about moving the particle in 2 and 3 dimensions, and you need to write down the equation of motion for that particle. If you are new to Introductory Physics 1 and like to learn more, hit the subscribe button and like for more. You ready? Let's get started. In this problem, ball starts at origin. It moves in x and y direction, and in the y direction it has acceleration for 3 meters per second square. In the first part, you need to calculate the total velocity of the ball. Let's see how you can solve it. So the parameter I have here is the initial time, which is t equal to 0, right? And then in x component, what I have is velocity is 4 meters per second. In y component is going to be 2 meters per second, and then in the y component acceleration is equal to 3 meters per second square, right? And we know for the velocity v is equal to a times t plus v naught, right? A is the acceleration, t is time, and v naught is the initial velocity. But here, be careful, you have two directions, right? X and Y. So let's write it down for X first. So my X gonna be like Vx, gonna be Ax t plus V naught, right? So in this problem, I don't have any parameters for Ax, right? So that means like I don't have any acceleration. So this part gonna be 0, and then my V naught gonna be 4, right? So my Vx gonna be 4. What about V in y component? Is gonna be Ay t plus V naught in y direction, and this is gonna be in x direction. And then my Vy gonna be, my acceleration is 3t plus 2, and 2 is the initial velocity. So if I wanna write down the velocity in total is gonna be 4 in x direction, so I have to have the unit vector here, and I is a symbol for the unit vector in x direction. And then for this guy, for the y component, I will have 3t plus 2 in y direction and the component, and then unit vector gonna be j. And this is gonna be my final answer for part A. Now let's look at the second part. For this part, I need to calculate the velocity and the speed of the ball at t equal to 1 second, and the angle of the velocity vector mixed with the x-axis. So for the velocity, I have found 4I plus 3t plus 2 in j direction, right? So for t equal to 1 second, my v gonna be 4I plus 3 times 1 plus 2, right, in j direction. And then is gonna be 4I plus 5j, right? And then for the angle, I have arc tangent Vy divided by Vx, and it's gonna be here, my Vy in y direction gonna be 5, in x direction gonna be 4, so it's gonna be tangent 1.25, that is equal to 51.3, and it's in degree, not radians. Now let's look at the next part. In this part, you need to find the position of the particle, but this time you have two coordinates, right? X and y. And one of your coordinates have the acceleration, the other one doesn't have the acceleration. So here you might think you have two options to write down the position of the particle. Let me write it down for you. The first one you might think of is x equal to vt plus x naught, right? The second one can be x equal to half of a acceleration t squared v naught t plus x naught, right? So which one do you think I should choose? Feel free to pause the video and think about it. If I go with the first option, there is no acceleration, right? It's all depend on the velocity, time, and the initial position, right? But if I look at this problem in y direction, I do have the acceleration, right? So for the y direction, I can't use the equation 1 because it doesn't have the acceleration, right? So I have to go with the equation 2. But what about the x component? So let's say for the x component, I don't have the acceleration, right? So for the first equation, I don't have the acceleration. For the second equation, I have the acceleration, but if I put it as a 0, then equation 2 and equation 1 gonna be equal, right? So for the x component, it doesn't matter if you go with the equation 1 or equation 2, because if I put the acceleration as a 0 in equation 2, equation 1 and equation 2 gonna be equal, right? Now let me write it down. I'm gonna go with the x-axis first. So if I go with equation 1, then my x gonna be 4t plus x naught, and is a start from the origin, and x naught gonna be 0, so this gonna be 4t, right? This is with the first equation, I'm gonna call it as 1. And if I go with the second equation, then I have half of a t squared v naught t plus x naught. Again, my initial gonna be 0. Acceleration is 0, so this part gonna turn to 0, and it's gonna be 4t with equation 2, right? So I end up with the same answer. Now let me write down for the y-axis. For the y-axis, again, I cannot use equation 1 because it doesn't have the acceleration. So I have to go with equation 2. So then what I'm gonna write is gonna be x equal to half of, the acceleration is 3 t squared plus my initial is 2 plus x naught, and my x naught gonna be 0, right? So then my x gonna be 1/2 t squared plus 2t. So if I'm gonna write down the position, is gonna be 4t in x direction, and then 1/2 in 1.5 t2 plus 2t in y direction. And this is gonna be my final answer for this part. I hope this example helped you to understand these subjects better. If you like my video, hit the like button and I'll see you in the next video.